Unit 3 review. Okay. So let's go ahead and go on. It says number 1, find and classify all of the relative extrema for f of x, which is this. Then find and classify all the absolute extrema on this interval. Okay, so relative extrema is that sort of thing where it's over the whole span, and really we just care about this area's critical points. So let's go ahead and do that. First, let's find f prime of x and solve for critical points. So we know that f prime is going to be negative 3x squared, negative 12x, and then minus 9. Um, from here, because we're going to eventually set this equal to 0, so it'd probably be in our best interest to start factoring already. So I'm going to factor out negative 3 since it shares that. X squared plus 4x plus 3. And then from here, you can go ahead and say, okay, well, you can use AC method or however you like, and this guy should be, it's going to be 1 and 3. Or you can use that square that you guys like to do. Um, let's do the square. I'm kind of warming up to the square idea. Uh, let's see. You have x squared. You do an x and an x. And then you have a 3 here. So you need to think of, okay, what factors of 3 can make these two combine into 4, and then you just hit it with 1 and 3. Multiply that, becomes 3. Then x with the 1, x with the 3, that does add up to 4. So you get x plus 1, x plus 3. So you technically have 3 things that when solving, you're going to set equal to 0. Negative 3 is equal to 0, x plus 1 is equal to 0, and x plus 3 is equal to 0. Here we know that that's just nonsense, doesn't make any sense, so this provides no information. Here we know that when x is negative 1, this equation becomes 0, and when x is negative 3, this equation becomes 0. So we have two critical points, negative 1 and negative 3. So now we have to do a sign test with these guys. So number 2. Do a sign test. Okay. So I have two critical values, negative 3 and negative 1. I have two big values in between, to the left and to the right of these, all evaluated under 3 functions. Negative 3, x plus 1, and x plus 3. And then that's going to help us evaluate the whole function. Okay, well, before I even start, I know that negative 3 will always be negative, so that's easy. Let's pick values in between. So I'm going to pick 0, I'll pick negative 2, and I'll just pick negative 4. Okay. So when this is negative 4, that will be negative, that will be negative. When this is, when x is a negative 2, that will be negative, and that will be actually positive. And then when x is 0, that'll be positive and positive. So the total sign value will be negative here. It'll be positive here, and it'll be negative here. So what this tells me is that on here, I'll do the number line. So what this tells me is the slope will be negative to the left of 3, and then the slope's increasing in between negative 3 and 1, negative 1. And at the right of negative 1, it's going to be decreasing. So visually, what does this look like? This looks like -3 will be a relative min, and -1 will be a relative max. Okay. Or minimum maximum. Okay. Although we're technically not done because this then further says, then find and you classify all absolute extrema on this bounded interval. So first we found the relative one, but now we need to check for the absolute extrema. But we are only looking between -3 and 1. So that's going to be slightly easy for us because for the absolute extrema, we're literally just going to be checking, the critical points and then -3 and 1. However, the critical points are -3 and 1. So actually, for the absolute extrema on -3 and 1, or -1, we're just going to check f of -3 and f of -1. And we'll see that we get, where's the order function varies? So negative parentheses -3 to the power of 3 minus 6 times -3 squared minus 9 times -3 plus 3. Yeah, I'm going to leave space so I can evaluate this. This is going to be a positive 27. This is going to be a negative 54. That's going to be a positive 27 again. And then that's going to be plus 3. Just double checking my math here. What does my solution say? Yeah. So all this will equal to 3. Now we check f of -1. We're going to do negative of -1 to the power of 3 minus 6 times -1 squared minus 9 times -1 plus 3. Here we get a 1. Here we get a -6. Here we get a plus 9. And then here we get a plus 3. Okay. So that means that our value here is gonna be, I don't know why I'm blanking out. 13. 13 minus 6, 7. Okay. Not that bad. But it is kind of okay. It's technically redundant for this problem, although I did accidentally give an easy one where we don't have to check the endpoints because the endpoints are the same, but we did sort of cap it at the min and max. So it's not like a crazy, thing, but it's just, it's a funky thing, I guess you can call it, where we see that further proof that this will be small and this will be large. So that means that -3 will be our absolute min, and -1 will be our absolute max. And then again on -3 to -1. Okay. Um, Actually, I should say x is equal. X is equal because it almost reads like I'm saying that the highest value will be -1, and that's technically not true. We found that the highest value is actually 7, but x is -1. That's where the highest value is. Okay. All right. Let's move on to number 2. Number 2 reads: a spherical snowball melts, so its volume just decreases at a rate of -48 pi cube inches per second. Okay. So, wait, is that a typo? Oh, this is a typo because decreases at a negative rate. The negative's already implied with the decreases. So my solution here includes a negative. So I'm gonna go ahead and take that out. So you would say decrease at a rate of this. At what rate is the radius changing when the radius is 6 inches? Let's recall the volume formula. Volume is equal to 4 over 3 pi times r to the power of 3. Take derivative with respect to r, so dv over dr, or no, dt, excuse me, is equal to 4 over 3 pi 3 r squared dr over dt. Okay, so from here, we can simplify that to be 4 pi r squared dr over dt. Okay, so now we need to see what we can plug in and what we can not plug in. So I'm going to copy what we did last time. It says the volume decreases at a rate of, so that means we're using the derivative volume, and 48. So I'm going to go ahead and plug in 48. At what rate is the radius changing when the radius is 6? So they want to know what this is equal to. So let's go ahead and plug in when the radius is 6. So 4 pi 6 squared dr over dt. I'm going to go ahead and just chug everything here. 4 times pi times 6 squared is equal to dr over dt. I can get rid of a 4 to make that 12 over pi times 6 squared. And I can get rid of a 6, or I should scratch off that, not this, to make this 2 over 6 pi. And then, see, am I missing anything else? I can factor out the 2 to get rid of 1 over 3 pi is equal to dr over dt. And that would be your final answer. The only thing that I want to double check, let me just see, is oh, so guess what happened? I forgot to include the negative. So funny enough, I was debating of what should I do if a student already did the review and then it's coming in. So funny enough, I did want to do a review where dv over dt was because it says decrease at a negative rate is the positive 48, and then now I'll do a separate one where I acknowledge that this is a typo, where it's dv over dt is a negative 48. So I'm just going to copy and paste it right here. Negative 48 is equal to 4 pi 6 squared dr over dt. Well, funny enough, we're going to do a lot of the same things. Cancel out, we get 12 over pi 6 squared. Cancel out a 6 to get 2 over 6 pi. Cancel out 2 to get negative 1 over 3 pi. And all of this is equal to dr over dt. Okay, so not a big difference, but it is, the classic, well, you forgot a negative problem, right? But yeah, that was a typo. So I'll double check because funny enough, I'm already making the test. But I'll double check if that snug it's going to test. If it did, then I'll take it out. Okay, all right, so let's go ahead and do number 3. So number 3 is evaluating limits. The gimmick here is that you can do it the hard way, but I'm going to give you I don't know if I'm gonna give you 4. I may give you 4, I may give you 3. I haven't decided yet. But the issue is that you need to remember L'Hopital's rule, the hospital rule, okay? Because if you do these by hand, that's gonna be nuts, okay? So please, please, please keep that in mind, okay? So for here, if you would evaluate it, you would have gotten 0 over 0, which doesn't make sense. So let's use L'Hopital, and you take the derivative of the top. So we get 3x squared, and derivative of the bottom, cosine of x. Do substitution first, and UCD you'll get 0 over 1, which is just 0. So let me hear 0. All right. Let's go ahead and do b. b, if I do 0, that's going to be 0 plus 0 over 0, which is still going to be 0 over 0, so that's invalid. So I'm going to use L'Hopital and do derivative of the top and the bottom. So it's going to be 1 plus secant squared of x over cosine of x. Okay. Well, we have 1 plus secant squared. Secant of 0 is actually just going to be, well, I'll go ahead and write it like this so I don't have to think too hard about it. So you see that for cosine of 0, it's going to be 1. So you'll have 1 plus 1 over 1 squared over 1, which this clearly will sum up to 2. And that's your answer. The limit will go towards 2. Over here, we'll plug in 0 again, and you'll get 0 on the top and 0 on the bottom. Let's use L'Hopital's rule. Do the derivative of the top. I get 1 half 1 over the square root of 1 plus x squared times the derivative of that, which is just times 2x. And then that's negative 1 canceled out, and then we're left with 2x. Okay. Well, here, I'm going to go ahead and abuse the fact that the 2x will cancel out, and I'm left with 1 over 2 times 1 over the square root of 1 plus x squared. Here, if I do substitution, I should get 1 half because that will become 1. That's my answer. Let me just double check. Okay, all right. Now I'm going to go ahead and do the derivative of this guy. This guy's a bit different looking, but I believe I have a similar trick. Yeah, the top for sure is going to equal 0 because it's going to be 2 plus 1 minus 3. And this guy is going to be, yeah, so that'll come out 7, that's minus 7. So we have 0 over 0. So that means I need to do a derivative. So 1, I have 4x plus 1 over 6x minus 7. Here, if I plug in 1, I'll get 4 plus 1 over 6 minus 7. And I'll get 5 over negative 1, which is just negative 5. Right. Those are my answers. Let's move on. I was about to ask any questions, but it's a video. 4. Find the antiderivative of this whole shebang. Okay. So let's go ahead and recall that the antiderivative is the thing where if I take the derivative of it, it should equal this with the space of a constant. So let's go ahead and propose that we're integrating. So 3x fifth, I'm putting all parentheses, plus 2 secant squared of x minus 5 over x minus 5e to the x minus 5 over x to the 4th, all with respect to x. Okay, so let's start here. That's a power, or I should color code this as well. Okay, so this is a power rule usage, so negative 3 x to the power of 6 over 6. Then here, we know that that secant squared, the only thing where a derivative of something equals secant squared is tangent. That's going to be 2 times tangent of x. Okay? Here we have the trick of the 1 over x, so we know that's going to be negative 5 ln of x. Okay, and here we have the exponential, so that's going to be negative 5 exponential x. And then last but not least, this guy over here, we can momentarily write as negative 5 x to the power of negative 4, but then you'll see they have negative 5 times x to the power of negative 3 over negative 3. Right. Then from here, we can simplify what we can and see what maybe cancels out or whatever. Right now, there's nothing that's going to cancel out. Oh, and then we forgot the biggest one, plus c. So let's go ahead and go with this. I'm going to have a negative x to the power 6 over 2. That stays the same. This stays the same. This stays the same. And then here, only thing really is that the negatives will cancel each other out. All right, that's pretty much it. The only thing I will say is remember, for antiderivative, you can double check your answer if you want to on the side by simply performing the derivative. If you perform the derivative, you should get back everything that you get up here. Even c, if you take derivative of c, you know it's going to be 0. So you should get back the answer. Okay. Alrighty then. Okay. Let's see. Next question. Oh, that's a typo. It's a bonus question, but I don't know if I'm probably not gonna make it worth 5 points. I increased the difficulty a little bit, so it's definitely not gonna be worth 5 points. Okay, alright. The mean value theorem. Let f be a continuous function over a to b and differentiable over a to b. Then there exists at least one point c such that f prime of c is equal to that rate of change. Use the mean value theorem. Let f of x be equal to sine of x plus x on this interval. So we know that on this interval it is continuous, or it's continuous in general, and it's differentiable in general, but especially on the interval. So we can go ahead and figure out the endpoints. So we know f of 0, which is just going to be sine of 0 plus 0, which is just a big 0. And then f of pi is just sine of pi plus pi. And then we get pi. And then we can construct that formula to be pi minus 0 over, by coincidence, pi minus 0, which is just 1. So we know that the derivative of this, which we can figure out right now, is cosine of x plus 1 can equal 1 with an x that's in between 0 and pi. So let's just check. Cosine of x plus 1 is equal to 1. Well, subtract 1 from both sides, and I get 0. And we know that we can find x's such that cosine of x is equal to 0. Namely, x is equal to pi over 2 plus pi k. And then we know that although there's multiple solutions, there is a solution that exists between 0 and pi. And that is pi over 2. Thus, the mean value theorem works. Okay, that's pretty much it for that one. Now we're going to do the thing like with the last review where we do another version of these. Let's do number 6. The mean value theorem. Let f be a continuous function and differentiable over a to b, then there exists at least one point c such that f prime of c is equal to this rate of change. Use the mean value theorem, let f of x be ln of x plus x squared on 1 to e. Okay. So we know that here it's not continuous everywhere, but it's continuous, and it's also not differentiable everywhere, but it's continuous and differentiable on this interval 1 to e. So if I find f of 1, I'll get ln of 1 plus 1 squared, which is just going to be 1. And if I do f of e, I'll get ln of e plus e squared, which is just 1 plus e squared. Then I can construct this rate of change. I'll have e squared plus 1 minus 1 over e minus 1. And that becomes e squared over e minus 1. Okay. Then, for this, we can go ahead and claim that there should exist an answer in between these two, where f prime, which in this case is 1 over x plus 2x, such that it equals this value. So we know that there exists an x such that this expression can equal e squared e to the 1 e over e minus 1 that's in between those two. Okay? For this, I'm gonna be honest, this is definitely not a test problem because this is going to be a bit lengthy, but I still decided to include it at least in the review because it is very reviewable. Like, oh, like this narrows down the example a bit better. I'm gonna go ahead and multiply everything by x, so I get 1 plus 2x squared is equal to e squared over e to the over e minus 1 times x. Go ahead and make it to where one side is equal to 0. And then I'm going to go and use the quadratic formula for this. So this is negative b, so positive, plus or minus the square root of b squared minus 4 times a times c, which is just 2 and 1, divided by 2 times a, which is 2. Okay? So if you plug in this expression in your calculator, taking one beat to do plus in the middle here, and one beat to do minus. Let me go and do it like this for everybody. Like I said though, this is definitely not going to be a how I say this. I wouldn't put a problem with this on your test because this has too many steps, but it's still like a good practice problem. Okay, so fraction first. We're going to do a fraction with an expression. It's e squared e minus 1. And then I'll do plus the square root of, again, this expression squared. Minus 4 times a times c, which is 8. And divided by 4. So I get a solution of 1.88 and 2.26, or let me just do 2.67. So for here, recall, by the way, that E is 2.171. We do see that there exists a solution, that 1.88, that is in between 1 and E. And thus, again, the mean value theorem. Wait, can you not see that? Oh, because the sun was lighting up. Well, the mean value theorem works. Okay. All right, let's move on. Number 7, find and classify all the relative extrema for this function, then find and classify all the absolute extrema. Okay. Let's start off with doing its derivative. So I get 4 e to the 3, x to the 3 minus 16x, and then that will disappear. From here, before I set equals 0, I can factor out 4 and an x to get x squared minus 4. And then from here, I can definitely go ahead and use difference of squares to get x minus 2, x plus 2. So when you set this whole thing equal to 0, you'll have 4 options that equal 0. You'll have 4 is equal to 0, x is equal to 0, x minus 2 is equal to 0, and x plus 2 is equal to 0. In all these cases, though, you do see that the 4 equals 0 doesn't provide any information. X equals to 0, well, that's just true. Or that can happen. I mean, it's not true, but it can happen. And when x minus 2 equals 0, then x is 2. And x plus 2 equals 0, then x is negative 2. So these three are our critical points. Okay? So keep that in mind. Because there are critical points, then we can go ahead and do the sign table with a -2, a 0, and a 2. And it's going to be for the 4, the x minus 2, the x plus 2, and then the function as a whole. So let's go ahead. Oh, I messed up the labeling of that. Where's my white at? Okay. So we need to pick numbers in between these guys. If this is going to be -2, that's going to be 0, and it's going to be 2, then I could pick 1 and -1 for here. I could pick 3, and I guess -3. All right, let's go. Well, 4 is going to be positive no matter what. And then we have x. Well, that's just a copy of what it is. So negative, positive, positive. X minus 2, that'll be negative with -3. That'll be negative with -1. This will be negative with 1, but it'll be positive with 3. X plus 2, that'll be negative here. That will be positive here, and then positive throughout. Okay? So then what's the whole sign? For here, it's going to be negative. For here, it's going to be positive. For here, it's going to be negative. And for here, it's going to be positive. So we can visualize this with a number line. -2, 0, 0, and 2. From the left, the slope will be negative. In between -2 and 0, the slope is positive. Between 0 and 2, the slope is negative. And after 2, the slope is positive. So here it's pretty easy to see what's a min and what's a max. So it seems like our relative max is at x is equal to 0. And our relative min is at x is equal to -2 and x is equal to 2. But then then the other part of the problem, we want to find the absolute extrema, but on that interval. So here's a bit tricky, because even though we have -2 and 2, we don't care about these guys because they're outside those bounds. So really, we should only be testing 3 variables. We should be testing the endpoints, so -1 and 1. We should also be testing the only critical point that's within those bounds, 0. So let's go ahead and test them out. We got -1 to the power of 4 minus 8, -1 squared plus 4. That's going to be 1 minus 8 plus 4. That's going to be a -3. For the 1, we're going to actually encounter the same thing. And then for 0, we will actually go as high as 4. So that means that on this bound, the absolute max is at x is equal to 0, and the absolute min is at x is equal to -1 and x is equal to 1. All right, that's pretty much it. Now, technically, right, this was another trick question where it chopped off the critical points, so it's good to keep that trick question in mind. Okay. Number 8, a crowd gathers around a movie star forming a circle. The area taken up by the crowd increases as a rate of 64 pi feet per second. How fast is the rate increasing when the radius is 2 feet? Okay, so this is just involving the area of a circle. So area is equal to pi r squared. Oh my god, am I blanking on the area of the rate of area? How embarrassing. No, yeah, it is pi r squared. I was testing you guys to see if you're paying attention to the video. Okay, so let's do a derivative with respect to time. We got a d over dt is equal to pi 2r dr over dt. Okay. Then from here we can fill in the blanks. It first says that the area taken up the crowd increases at a rate of 64 pi. So that's going to be 64 pi. And then was how fast is the radius increasing? So when the radius is 2 feet. So you want to know when it's 2 feet. Okay, so this is kind of straightforward. 64 pi over 4 pi dr dt. We can just divide by 4 pi. Dr over dt divided by 4, 16. So it's going to be 16, or 16 feet per second. All right. That's pretty much it for this one. Okay. We got the last two. So evaluate these limits. Again, you're going to get these problems. They're going to take longer or extremely long if you try to do it with everything but Hospitals. So please remember Hospitals. Okay. All right, here we got 0 plus 0 over 0 minus 0. So that's going to be 0 over 0. So we're definitely doing the Hospital. The top will be 1 plus 3 cosine of 3x over 1 minus 3 cosine of 3x. The limit as x goes to 0. So plugging in that, we get 1 plus 3 over 1 minus 3. 4 over -2, that's going to be -2. Okay. That's free. Here, let me just check my solutions. I shouldn't be too reliant on the solutions, but I can't help but to double check my work. Okay. B here, this is going to be a 0 plus a 0 over 0, which is 0 over 0. We can use the Hospital. Drawing that secant squared of x plus 1 over 2. So, I'm sorry, that's definitely a trig identity, but we don't need to use it. We know this is going to be 1 plus 1 over 2 when we plug in the 0, so we get a 1 as our answer. Okay. Over here, that's going to be 0 over 0 again. Let's use the L'Hopital. We have limit as x goes to 0 for the top, which is 1 over 2. 1 over the square root of 9 plus x. And then the derivative inside is just 1, so we don't have to worry about that. And this is also just 1. So I get simplified 1 over 2 plus times 1 over square root of 9 plus x. We can plug in a 0, and we'll definitely get 1 over 2 times 1 over 3, which is 1 over 6 as our final answer. Alright, last one we have for 4. Let's quickly evaluate. We got 2 times 4 squared minus 11 times 4 plus 12 over 3 times 4 squared minus 13 times 4 plus 4. Okay. Let's see, we got a 32. We got a minus 44, and then we got a 12, so that's going to be equal to 0 on the top. On the bottom, we have, let me just do that out loud, 32 plus 16, 8, 4, so 40, 48 minus 113 times 4, 52, so minus 52 plus 4, yeah, it's definitely going to be 0 as well. Use a L'Hopital. And I get 4x minus 11 over 6x minus 13. And I can definitely just plug in 4 for these guys. I get 16 minus 11 over 24 minus 13. That becomes a 5 on the top, and that becomes an 11 on the bottom. Let me just double check. Yeah, okay, cool. And that's your answer. Alright, last one, number 10. Number 10. Find the antiderivative for all this. Recall the idea of the antiderivative. You're going backwards. So you're treating this all like an integral. 1 over 2 square root of x minus 4 cosine of x minus 1 over x minus e to the x minus 3 over x to the power of 3. All with that dx in mind, okay? Let's just go one by one. Here, we can technically rewrite this as 1 over 2 x to the power of negative 1 over 2. And that'll just become 1 over 2 times x, adding 1 to be 1/2, and then adding 1, or same power 1/2. Oh, that was just the square root. Well, either way, it's good to practice it like this anyway. Okay. Then over here, we see that it's going to be a negative cosine, so that goes back into a positive sign. So plus 4 times sine of x. Oh, wait, no, that's a typo. I'm confusing with cosine. I'm going too fast. How much video? Oh, around 44 minutes? I'm not going too fast. Well, maybe y'all disagree. I don't know. We'll see. But that's going to be negative. Sorry. Okay, here, I'll fix that when it dries. Then over here, oh, that's just ln, so negative ln of x. Same thing over here, that's going to be just a, oh, let me just do color. It's going to be a negative exponential And then, hold on. Over here, you can rewrite it as -3 x to the power of -3. So we have -3 x, you add 1, so -2 over -2. Okay. Um, let's go ahead and now definitely simplify things. And then we need to include the plus c. C. From here, those technically cancel out, so there's just square root of x minus 4 sine of x minus ln of x minus e to the x. Here, that just becomes a positive 3 over 2, 1 over x squared plus c. And double check. Yep, that's it. We are done with this review. Okay. Let me know if you guys have any questions. Okay, I'll be behind my computer all day Thursday. So please, please, please keep that in mind. Okay. All right. I wish you all. Oh, okay. Wait. Actually, to be super transparent, I probably will stop being behind my computer. I will be on the road because I have to be at a just trauma dump. Sorry, I have to be at a funeral by Friday morning. So I will be on the road by Thursday night. Okay. So please message me before 5. Okay. Don't worry about the test being uploaded. You should have all of that already. Like that's something I'm gonna do automatically. So there shouldn't be a test delay unless it's an unforeseen technicality. But everything on those regards should be good. All right. Let me know if you have any questions. I'll see you all in the next video. Bye bye.